Good morning. This is your stats sensei, Mr. Spensei, and we are going to run a chi-squared test. This is based on warm-up scenario number 2, and this is going to be classwork. I'm a loser, baby. A contestant who lost at this game alleges that the wheel is not fair. In order to check on the fairness of the wheel, the data in the table below were randomly collected. Yours should say randomly collected from 100 spins of the wheel. So that looks like a sample size. During a night in which there's 11,350, the wheel is spun 11,357 times. That sounds like the population. All right. The result, they got $0 33 times, $100 21 times, 220 times, 526 times. Based on the data, can you conclude that the 4 outcomes on this wheel are not equally likely? Not the same. Give the statistical evidence to support your answer using a 5% level of significance. All right, so apparently they're spinning the wheel, see how they perform. So our first thing we need to do is identify. Oh, also we have a list of values. We have a list of values here, and they want to know if they match what's expected. Well, what's supposed to be expected? Well, if I expect that they're supposed to be equally likely, I should win 1, 2, 3, 4. So 100% divided by 4. If I take 100 divided by 4, I should get 0.25. So this ends up being 0.25. This ends up being 0.25, 0.25, and 0.25. So I should be winning 25% of the time. All right. So because we need to match the distribution, we're looking to see if they're not equally likely or if they're the same or not. This makes it a chi-squared test of goodness of fit. So the 4 by the way, what I've highlighted in red, yellow is what you should have. The 4 outcomes are equally likely, or you could have said are the same. If they are the same, the wheel is fair. And by the way, that's a positive comment. The wheel is fair. So this right here, the hoe is positive. They are the same. They are equally likely. You could have said, if you were really careful, that they follow a uniform distribution, because uniform distribution means they're the same. The distributions are not equally likely. They are not the same. Well, not is a negative statement. That must be my ha. So in that case, if they're not the same, the wheel's unfair. It's not equally likely. They have a random sample of 100 that was given. We know we have a population of 11,357. So our sample size times 10 is 1,000. That's less than this. So we meet the n is less than 10% condition. And all expected values are greater than 5. And we can see the table below. Our formula is chi-squared equals observed minus expected squared over expected. Degrees of freedom. For a goodness of fit is just categories minus 1. Well, if I look, I have 1, 2, 3, 4 categories. So 4 minus 1, and I have 3 degrees of freedom. We need to check our expected values. Well, for chi-squared goodness of fit, I need to go into stat edit. So we're going to go stat edit. And I've got stuff in there that I need to clear out. So I cleared it out. So I need to put the results in my column 1. This is what I actually observed. And I go 0, enter, 100, enter, 200, enter, 500, enter. All right. And then I put my probabilities in 0.25, 0.25, 0.25, 0.25. Because they said they're supposed to be equally likely. That's what we're expecting to happen. We're expecting this to happen 25% of the time. All right. That's not where we stop. If you stop there, you will get the wrong answer. So I need to go second, followed by number 2, and multiply by the sample size. Well, our sample size was 100, so I'm going to multiply by 100. And I get 25. There should be exactly 25 of each of these. And we see that we have some above 25 and some below 25. We need to record it for each one of these. All right, once we have our data in here, we can go ahead and do our plug. And our plug is always going to be the first one and the last one. So I care about this one right here, and I care about this one right here. So chi-squared equals 33 minus 25, observed minus expected over the expected, plus dot 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 plus observed minus expected over expected. So let's go ahead and run this thing. So we're going to go to stat test, and we need to make sure we choose GOF for goodness of fit. That's letter D. Degrees of freedom. Well, what do we have? 1, 2, 3, 4. So 4 minus 1. When we press calculate, and oops, I have a problem. I input the wrong values there. I did not put in my observed. So this should be 33. This is 21. Some of you are probably wondering if I was ever going to catch that, but I did. Sorry it took this long to do it. There, we needed not the winnings, we needed our observed values. We observed 33 wins, 21 wins, 20 wins, and 26 wins. So stat, test, go back to chi-squared goodness of fit. We still have our 3 degrees of freedom. And we end up with a chi-squared value of 4.24 and a p-value of 0.236. So the probability that it's chi-squared is greater than 4.24 equals 0.2366. That's definitely greater than alpha. So we're going to fail to reject. The p-value is 0.237. We fail to reject a null. There is not sufficient evidence that alpha equal 0.05 to suggest that the 4 outcomes are not equally likely. Or you could say are not the same. All right, what I have highlighted is what you're supposed to have. You have to have that. And we can say that there's not sufficient evidence to suggest that the wheel is unfair. We don't have enough to say that the wheel is unfair. All right, I hope that helps. Sorry for the error on the calculator entry. I'm going to put that back up there. All right, make sure you have your observed in here, expected there. And I hope to see you on the next one. Thank you.